Hello guys, welcome to VKML. In this lecture, we will solve example based on the different concentration term. First example is a commercially available sample of sulfuric acid is 15% H2SO4 by weight. Density given 1.10 gram per ml. Calculate molarity, normality and molarity of solution. First we calculate the molarity. So molarity is equal to number of moles of solute divided by the volume of solution. In the given data, only given 15% of solution. What is the meaning of the 15% solution? We know that the 15% means 15 gram of H2SO4 dissolved in 100 gram of water. So 15 gram is the weight of the solute. And that H2SO4 means its molar mass 98. So how to find out the mole? Mole is equal to weight upon molar mass. H2SO4 weight is 15 gram divided by 98. So moles is equal to 15 by 98. Put this value 15 by 98. This is the moles of solute. Then find out the volume of solution. So volume of solution given is the 100 gram. This is the mass. But find out the volume. Density is given. So we know that the density is equal to M by V. M value 100 gram and density value 1.08. So V is equal to 100 divided by 1.10. So this is the 90.09 ml. This mole 15 by 98 and that volume of solution. So it's multiplied with 90.09 ml. This value is the ml, so it's multiplied with 1000. It gives the molarity. We know that the normality is equal to the number of gram equivalent of mass. Gram equivalent mass of the solute divided by the volume of solution. First we know that the gram equivalent of solute. So gram equivalent is equal to mass upon equivalent mass. In this the given value mass is equal to 15. So that is the 15. Then find out the equivalent mass. How to find out equivalent mass? So equivalent mass is equal to molar mass upon N factor. In the N factor is H2SO4. So N factor is acid. Acid means numbers of H plus ion. N factor means number of H plus ion. In the H2SO4, number of H plus ion is 2H plus SO4 minus 2. So this is the 2H plus. That way molar mass is equal to 98. H2SO4 molar mass 98 and N factor is equal to 2. So this divided by 2. Its answer is 49. So 15 by 49. The gram equivalent of solute is equal to 15.49. Then volume of solution multiplied with volume of solution is the 90.09 and it's ml, so it's multiplied with 1000. It gives the normality. Third term is molality. Molality is denoted by the M. That means that the moles of solute means solute is the H2SO4 and weight of the solvent. That is the 15 gram H2SO4. That means 15 gram of H2SO4 dissolved in 100 gram of water. So 100 gram is the solution and 15 gram is solute. So we find out that the solvent 100 minus 15. So 85 gram is the solvent. This is the solvent. So weight of the solvent is 85 gram. Moles of H2SO4 given is 15 by 98 and weight of the solvent is 85 gram. This is the value of the gram. So it's multiplied with 1000. Its answer is gives the molarity. A sugar syrup of weight 214.2 gram contains 35 32.2 gram of sugar. Calculate molar concentration and mole fraction of sugar in syrup. Calculate, given is the molar concentration. Molar means molality. It's denoted by the M. So first given data is the sugar syrup of weight. Weight of sugar syrup is equal to 214.2 gram. That contains 34.2 gram of sugar. So weight of sugar in sugar syrup is equal to 34.2 gram. Then weight of water in sugar syrup is equal to, this is the minus. So 214.2 gram minus 34.2. This is the 180 gram. That way the weight of water is equal to 180 gram. Find out the molar concentration. Molar concentration is equal to the moles of solute, means moles of sugar, divided by the weight of solvent. First find out the moles of sugar. So moles of sugar is N is equal to W upon M. Moles of sugar means weight of sugar is equal to 32.2 divided by the M. Molar mass is equal to 342. So this is the 342 divided by 342 multiply with 10. This given is the 0.1. So moles of sugar is 0.1 divided by the weight of solvent. Weight of solvent is water. Because of this is the solution. This is the solute. So this is the solvent. Solvent is equal to 180. This is the gram. So multiply with 1000. It gives the value of the molality. We know that the mole fraction of sugar in syrup. For example, mole fraction of sugar, it's denoted by the S. Mole fraction of sugar is equal to the NS upon NS plus solvent. So this solvent is water. So that's denoted by the NW. NS, we know that the mole of the sugar is 0.1, that 0.1 plus NW means moles of the water. How to find out? N is equal to W upon M. So W upon M, weight of water is equal to 180. And molar mass of the water is equal to 80. It gives the 10. So 10 mole of the water. 0.1 divided by the 10 plus 0.1 is equal to the mole fraction. This is the mole fraction of sugar. And 1 minus this X is given is the mole fraction of water. Next is, an antifreeze solution is prepared from 222.6 gram of ethylene glycol and 200 gram of water. Calculate the molality of solution. If the density of solution is given, what will be the molarity of solution? In this question, we find out that the molarity and molality. Molality and molality. First, we find out that molarity. Molarity is equal to the moles of solute. Moles of solute means, in this question, moles of solute is ethylene glycol. So C2H4OH twice. And mass of solvent. Mass of solvent. So in this question, solvent is water. Mass of water. First, we find out that the moles. How to find out moles? N is equal to W upon M. Weight upon molar mass. Given weight is equal to 222.6 divided by the molar mass. Molar mass is equal to sum of the total atomic mass. So that is the 2 into atomic mass of the carbon plus 4 into atomic mass of hydrogen, 2 atomic mass of oxygen and 2 atomic mass of the hydrogen. So 2 carbon 12 plus 4 hydrogen atomic mass 1, oxygen 16, 2 and H. That is the 24 plus 4 plus 32 plus 2. 6 and 30. 30 plus 32 is equal to 62 gram per mole. So that molar mass is 62. That molar mass 62. 222.62 divided by 6 into 3. 3.57. This is the moles of C2H4OH twice. So moles is equal to 3.57 divided by the mass of water. Mass of water given is 200 gram. And this is the gram, so multiply with 1000. It gives the molality. Molarity M is equal to the moles of ethylene glycol divided by the volume of solution. We know that the moles of ethylene glycol is equal to 3.57. Find out the volume of solution. How to find out the volume of solution? Given data, density is present. So density is equal to M by V, where V is equal to M by rho. M is the mass of solution. Mass of solution. In this, that is the solute and that is the solvent. So solvent plus solute is equal to the mass of solution. So mass of solution is equal to 222.6 plus 200. So that mass of solution is 422.6 divided by the density 1.072. This gives the volume of the solution. So this value put in this equation, 422.6 multiply with 1.072. This value in this gram, so it's multiply with 1000. This gives the molarity. The mole fraction of the solute in 2.5 molar aqueous solution. First we know that what is the meaning of the 2.5 molar aqueous solution. 2.5 molar means 2.5 moles are dissolved in 1 kilogram of solvent. 1 kilogram means 1000 gram. Then find out the mole fraction. Mole fraction of the solute. It's denoted by the XS. So that is the moles of the solute divided by the moles of the solute plus moles of the solvent. That is gives the mole fraction of the solute. Then this is given is the 2.5 mole of the solute. So 2.5 divided by 2.5 plus moles of the solvent. Find out the numbers of mole of the solvent. So N is equal to W by N. W is given means the weight of the solvent is 1000 and this is the water. Aqueous solution means solvent is water. Its molecular mass is 18. So it gives the 55.55 numbers of mole. 55.5. It gives the mole fraction of the 2.5 molar aqueous solution. Calculate the volume of 80% H2SO4 by weight required to prepare 1 liter of 0.2 molar H2SO4. In this type of question, when prepare solution data, volume and molarity is given. So we apply the molarity equation. Molarity equation is equal to M1V1 is equal to M2V2. For example, consider that is a M1V1 or M2V2. In this question, we consider as the M1V1. So M1V1 is the prepare. This required to prepare. This solution is prepare. How to make this solution? So it's known as the prepare. And M2V2 calculate. So it's known as calculate. Or you given as the A or B, any type of name. So M1V1 is prepared. Data given is the M1 is equal to 0.2 and V1 1 liter ml converted into 1000 gram. Then we calculate the volume. Calculate the volume. So this volume is calculated. And M2 we find out. M2 is find out. How to find out M2? We know that the molarity is equal to moles of solute divided by the volume of solution. Given data is 80% H2SO4. That means that 80 gram of H2SO4 dissolved in 100 gram of solution. So 80 gram is the solute and 100 gram is the solvent. So 18 gram moles of solute. How to find out the moles of solute? That is H2SO4 is a 98 and this is the 80. So N is equal to W by M. Moles of solute, W is equal to 80 gram divided by 98. This is the moles. So 80 divided by 98. multiply with volume of solution. Rho is equal to m by v. V is equal to m by rho. M is equal to 100 gram. So that is the 100 divided by 1.80. 100 in grams, so multiply with 1000. And this value put in this equation, 100 multiply with 1.80. This gives the value of the molarity. This molarity value put in this equation. So we find out that the V2. Next is the mole fraction of benzene in solution with toluene is 0.5. Calculate the mass percentage of benzene in the solution. Given data is the mole fraction of benzene is equal to 0.5. That we assume that the mass percentage of benzene is X. Mass percentage of benzene X in 100 gram of solution. So we calculate the toluene. That is mass percentage of toluene is equal to 100 minus X. Total 100 in the 100 gram X percentage benzene and 100 minus X percentage toluene. Then find out that the mass percentage of benzene. Mole fraction given, so mole fraction of the benzene is equal to the moles of benzene upon moles of benzene plus moles of toluene. How to find out the moles of benzene? N is equal to W by M. This is the weight. So mass percentage weight is X divided by the molar mass of the benzene is 78. Then next, moles of the toluene, W by M. That weight is 100 minus X divided by 92. This value put in this equation. So moles of benzene is equal to X by 78 divided by X by 78 plus 100 minus X by 92. Solve this equation. X by 78. This is the 1 upon multiply with 92 X plus this 78 100 minus X divided by the 92 into 78. X by 78 multiply with 92 into 78 divided by 92x plus 78 100 minus X. Then this values XB is equal to 0.5. Then solve this equation. X is equal to 45.2%. That means the mole fraction of the benzene in solution given 0.5 and given mass percentage of benzene in this solution is the 45.2%. And another, find out that the mass percentage of toluene. So mass percentage of toluene is 100 minus X. So 100 minus 45.2 is given is the mass percentage of toluene. A sample of drinking water was found to be severely contaminated with chloroform, supposed to be carcinogen. The level of contamination was 15 ppm. Find out that the percentage by mass and determine the molality of chloroform in water sample. First is the percentage of mass. Percentage of mass is equal to the mass of solute divided by mass of solution multiply with 100. So 15 ppm, meaning of the 15 ppm is 15 gram of solute or chloroform dissolved in million, means 10 raised to 16 gram of solution. So 15 gram of solute, mass of solute is 15 divided by mass of solution. Mass of solution is 10 raised to 6. Multiply with 100. So this gives the percentage of mass. Next, determine the molality of chloroform in water sample. So molarity is equal to the moles of solute divided by the weight of solvent. How to find out the moles of solute? So N is equal to W by M. Weight given is 15 divided by the molar mass. Molar mass of the chloroform is the 119.5. So that is the mole. This value put in this equation, 15 divided by the 119.5. Then weight of solvent. Total solution weight is equal to 10 raised to 6. So solution is equal to solvent plus solute. Solution value 10 raised to 6 is equal to solvent plus solute 15. So solvent is equal to 10 raised to 16, 6 minus 15. So see, this is the nearly about the 10 raised to 6. Because of the 10 raised to 6 is very large amount and 15 is very minor amount. So 10 raised to 6 minus 15 nearly 10 raised to 6. Put this value, weight of solvent 10 raised to 6. This is the gram. So multiply with 1000. It gives the answer of the molality. Which is a 6.90 molar solution of KOH in water contains 30% by mass of KOH. Calculate the density of the KOH solution. First given data is the 6.90 molar. That means that 6.90 moles of KOH dissolved in 1 liter solution. And 30% meaning that 30% is 30 gram of KOH dissolved in 100 gram of solution. Find out the weight. In this the weight is the 30 gram. And that means the 6.90 mole. So N is equal to W by M. N value 6.90. Weight find out. Molecular mass given is the 56. So weight is equal to 6.90 into 56. That gives the 386.5 gram. Weight given is the 386.5. And that is the 30 gram of KOH dissolved in 100 gram of solution. Then this 386.5 gram of KOH dissolved in solution. How much ml of solution? How much gram of solution? So that is the 386.5 multiplied with 100 divided by 30. So that gives the total number of the solution. So solution answer is the 1288 gram. Then find out the volume. So calculate the density of the solution. The density is equal to M by V. So density find out. M value is the 1288 divided by the volume of the solution. For the volume of the solution, this is the 1 liter of solution. That means the 1000. So its answer is 1.228 gram per ml cube, centimeter cube.